I'm so freaking hungry, man. I'm full now.
Hi everyone, I'm Watcharapat and I'm going to be presenting the next part of our project, which is the test case design. The first one being the combination testing. The challenge that we face is that our function, the calculate spread one, uses 5 different input parameters. And if we try to test out every combination, it will quickly become too many test cases, which is what we call a combinatorial explosion. And to solve this, we use a pairwise testing, otherwise known as the two-way combinatorial testing. By doing, instead of testing everything, we make sure that every possible pair of input parameters is tested at least once. The value we get from this approach is that it significantly reduces the number of test cases while still maintaining a high chance of catching a bug. So we get a efficient testing without sacrificing quality.
For our goal to scientifically prove that our test suite is actually effective at catching bugs, rather than just achieving code coverage. For the process, we deliberately inject artificial faults or mutants into our source code, such as changing logical operators. And for the validation, for our test to be considered successful, they had to kill the mutants by achieving A. Reachability, executing the mutant line of code, B. Infection, altering the program internal state, and C. Propagation, forcing a test failure at the final output level.
Moving on to software quality assurance. First, testabilities. We use requirements testability metrics as the backbone of our process. This ensures that every single requirement in our project scope is directly mapped to a specific function in the code and also verified with an automated test case. Next, data contracts. The SQA process actually changed our perspective. Instead of just creating UI input box, we start defining clear data contracts between the front end and back end to ensure that any input from the user must follow strict safety and validation rules before sending to the back end.
I think we're done, right? That's all of our code.
Yeah. We already finished all the projects.
So I guess we're gonna push it up to the production GitHub and hopefully it's work.
Yeah. On 3, let's go.
2,
1. Yeah!
Have you run the test before we push it on the code?
I think I already ran the test. I test the code. Yeah. But I don't think it's nothing wrong with it. Let me check my result right here. Oh yeah, everything down. Okay. Seem like what we test is the ask ball function and calculate function is down for some reason. And it's not even my fault, there's integer overflow fault. For calculating, if you put too much number, it's return infinity. It's not my fault, it's programming fault. Yeah, right? And for ask ball functions, I see that I didn't prevent the way that connect database and then it down. And yeah, he's not even deployed the database yet. Man.
Oh, so he was the one who tested the code? Okay, don't tell me he didn't also put the database into the code.
Oh yeah, so I forgot that it's my part to depart database. What are you guys doing in the dark? Do you know that our server just down? What? And our shareholder is yelling at me. You know what that's called? Who did that?
It's you.
No, it's him. You two are so fired right now. I'm gonna go back and talk to the shareholder.
We're so fired, dude.
Fired. Let's go to a taxi. Yeah. We should be a driver.
Good job, tester. It's time for the questions.
Now time for the question. Question number 1. How do you ensure test case cover real user flows, not just individual functions?
So, in order for us to achieve our goals with such a big scale project, right? We use a requirement traceability matrix, or RTM for short, to link every of our process. So it also gives us an advantage when we test for the process, like since you click the UI and put in numbers until the data is added to the database, we only run the test only there, not like individually, because we have RTM covering everything for us. And that's how we can cover everything in our testing.
Now for the number 2. Did you encounter a situation where unit test passes, but the system test fail, and what caused it?
So we have this function, right, called calculated spread. So we can input a number and select the scores and stuff, right, and a little bit more of a detail, and it can calculate the spread. So for normal numbers, okay, 100, maybe like 20, 30 works, okay, but the system fails when you input a too big number, like 10 million, right, So when that happens, the system fails and the program returns NaN, N-A-N, or, okay, of course, not a number, which is one of the system fails we get.
Okay, next one. How did you validate correct behavior beyond just checking status codes?
Okay, so we did not just looking forward for the 200 success code, but we use the method called control flow and data flow analysis to observe since the start of the variable to the end and to the database that what happened to them, and we track the result from that.
Okay. For negative test cases, how did you decide which invalid scenarios were important?
Okay, so if we talk about the high safety risks, it's gonna go like for the duplicate or the toxic entries. Since we have like a million of combination input that we can do, we're gonna use the pairwise testing to make sure that every possible outcome is matched together and have been tested without wasting our time.
Okay, for the final one, if you had more time, what else would you test to improve reliability?
Okay, so talking about more time, we would go with the stress testing of our projects, because right now we have no idea how the project can handle how many of the user can use in our system. Yeah, so I'm gonna go with that.
Okay, that is all the question. Thank you so much, YouTube.
Please
don't fire us.
Yeah, please don't fire us, dude.
I will cut your salary down from that time that you say 2 to only 1. for this
Again?
year.
What? Yeah. Oh.